Let's get out tonight's homework. Tonight we're going to be practicing some skills that we've learned in Unit 3 so far, which would include exponents that are zeros, negative exponents, as well as multiplying exponents. So let's get out our sample problems and do some together. If we look at number 5, it says choose a fraction to use as a value for the variable a. And I'm just going to assign the value a is equal to 1/2. Okay, you can plug any value in, so you might have different answers than me. But just put a fraction there. I'm going to put 1/2 in. And then we need to substitute for a to the negative 1 power. What would that be? A to the second power and a to the negative second power. Well, let's do this one first. Let's switch our color up here. I'm going to go here. Okay, so a to the negative first power. I'm going to substitute 1/2 in here. 1/2 to the negative first power would be simply this. I just have to remember I'm not doing repeated multiplication, we're doing repeated division. So this would be 1 over 1/2 to the first power, which is 1/2. And I know that when I divide by a fraction, I'm really multiplying. So this would be 1 times 2 over 1, which is going to be 2. Okay, now see, what I do, I first substituted, okay, and then I said, okay, I want to raise 1/2 to the negative first power, which means I'm doing repeated division. In this case, I'm really not repeating that often, but it's 1 over 1/2. I know that 1 divided by 1/2 is the same thing as 1 times its reciprocal, so I copied the first number down, I changed my division to multiplication, and then I flipped my fraction 1/2 to its reciprocal, 2 over 1. And then I multiply through. 1 times 2 is 2, and 1 times 1 is 1. And I know that's going to, 2 over 1 is 2. Okay, let's take a look at the next one. Okay, a to the second power. So what do? I substitute 1/2 in for a, and I raised that to the second power. So that's just 1/2 times 1/2, which is 1/4. Easy enough. That's my answer for that. And sure, why not? Let's change the color. Okay, if I have a to the negative second power, I'm going to substitute my 1/2, or a with 1/2, and now I'm raising it to the negative second power, which means I'm doing repeated division. So that would be the same thing as 1 divided by 1/2 to the second power. I already figured out over here that 1 to the second power is really 1/2 times 1/2. So keep going down the slant here. I get 1/2 times 1/2, which would be 1/4. Okay, all I did was I multiplied 1/2 times itself, because I've got it squared here. And then when I divide by a fraction, I'm really multiplying by its reciprocal, so it's that copy dot flip strategy. So I copy my first number down, I change my division to multiplication, and then I flip my fraction to its reciprocal, which is 4 over 1. So when I have 1 times 4 over 1, which is really 4, my final answer will be 4. Okay, let's take a look at 1b. 1b, we have 4 times x to the 0 power times y to the negative 2 power. We need to simplify this, and in order to simplify, we need to ask ourselves, are there any common terms that we can combine? Not really. Are there any operations that we can carry out? And the answer is most definitely. The first one I'm going to do is an exponent. There's no parentheses, so I jump right to exponents in my order of operations, and I would just read left to right. X to the 0 power is my first one. Now, you might say, I don't know what x is. Well, it doesn't really matter, because I know the zero law for exponents is this. Anything to the 0 power is always 1. So x to the 0 power is going to be 1. And then I'll bring down the rest of my information. Whoops, let me change that to blue. times y to the negative second power. So I brought that down and then brought that down. Okay, so I brought down all my information. Next step, well, I need to do my next exponent, and I know that y to the negative second power really means I'm doing repeated division rather than multiplication. So rather than, y to the second power would be y times y, but y to the negative second power is saying I'm going to divide by y to the second power. And I bring down my 1, and then I still have my 4. Okay, and I can stay with my colors now. 4 times 1 will be 4, and then when I multiply that by 1 over y to the second power, I just multiply straight through. 4 times 1 is 4, and I know that 4 is really 4 over 1. I'll just write that in there. 1 times y to the second power is y to the second power. And that is our answer. Let's look at number 3. Now number 3 is pretty simple. What we have is we have a to the nth power times a to the negative nth power. Now I know the rule is anytime that I have two exponents that I'm multiplying, if they have the same base, the base is going to stay the same, and then I just add the exponents together. So I have n plus a negative n. Okay, and anytime I add the negative of something, whether it's 1 and negative 1, or 5 and negative 5, or negative 10 and positive 10, when you add their opposites together, you always get 0. Okay, and anything, as long as this variable, this number here, is a non-zero, okay, anything raised to the 0 power is going to be 1. I have a to the 0 power, so that's, you don't have to know what a is. You know it's going to be 1. Because, and why is that true? Remember, a to the 0 power is really a over a. So anything divided by itself is going to be 1. Problem 2c, we have 6c to the second power over b to the negative first power. Okay, well, not much is going to happen in our numerator. Okay, we can't really do much with that, so that pretty much stays the same. But I know, once again, that when I have a negative exponent, I'm doing repeated division, not multiplication. So this will become 1 divided by b to the first power, or just b. And I'm going to go back to my multiplying, or I should say dividing fraction skills, which I know the first step is, see what I'm doing here is I'm taking 6c to the second power and I'm dividing it by this fraction, 1 over b. So you copy your first term down, which is 6c squared, and then I change my division to multiplication because I'm really multiplying. I'm going to multiply by my reciprocal, and then I flip this fraction to its reciprocal. So I flip, okay, I flip that to 1 over b to b over 1. Now someone might be saying, well, what happened to my exponent b to the first power? Well, b to the first power is just b, so we really don't need to make it any more complicated than that. And then I multiply straight through. 6c squared times b is 6c squared b, and then over 1. Okay, and it's kind of ridiculous. I really don't need to have that, so I can just, anything divided by 1 or over 1 is itself. So my final answer is that. Okay. The next problem we'll be looking at is 1e, and this is 1 over 4 to the negative third power, or 1 divided by 4 to the negative third power. And I need to, first thing is, I'm just going to transfer this over. Okay, and what does 4 to the negative third power mean? It means 1 divided by 4 to the third power. I'm doing repeated division here. A negative exponent means repeated division. So I'm dividing 1 divided by 4/3, or 1 over 4, not thirds, 4 to the third power, 4 cubed. Okay, let's see if the little blast from past. Anytime I divide by a fraction, what am I really doing? I'm multiplying by its reciprocal. So what I have to do here is I take my first number, which is 1. That doesn't change at all. And then remember, that's copy. I copy my first number down. And then dot. Okay, I'm instead of dividing here, it's 1 divided by 1 over 4 cubed. Well, now I'm going to, instead of dividing, I'm going to multiply by its reciprocal. So this guy right in here, okay, this guy right here is going to, I'm going to have to flip it to its reciprocal, which will be 4/3 over 1. Okay, I just flipped it. Now I can multiply. Multiplying fractions is easy. Okay, numerator times numerator. 1 times 4 cubed would be 4 cubed. And then this is really over 1. 1 times 1 in my denominator is that. Oh, wait, let's clean it up a little bit. Really, it's, okay, because anything divided by 1 is itself. So my answer is 4 cubed, which, oh, I can take it one more step. I know that that's 4 times 4, which is 16 times 4, which is 64. So if you want to get really simple, that's my final answer. Multiplication property of exponents. So what we're doing here is we're multiplying exponents. And when I'm multiplying exponents, let's model 4 first. Let's go out of order here. Okay, I know that x times x squared times x cubed is really x times x, right? Times x times x times x. Okay, there's my x, there's my x squared, and over here I have x cubed. And when I multiply this through, okay, I'm going to get this in exponential form. It's going to be equal to 1, 2, 3, 4, 5, 6, x to the 6th power. Now there's a rule or a shortcut that I can come from this. If I just take, if I'm multiplying, okay, an exponent by an exponent, or in that case, here I have 3 exponents I'm multiplying, and the base is the same, I know that my base won't change, okay? So if the bases, they all have that in common, and then all I do is I've got x to the 1st power here, and then I've got x to the 2nd power, which is 2 more x's, okay? And then I've got x to the 3rd power there, that's the 3 more x's. So what really a shortcut is I can just add up their exponents. I'm still multiplying x times x times x the amount of times I'm supposed to be, but I see a pattern here. I see a shortcut that if I just add up all of my exponents, and even though here it's not written, okay, you don't write x to the 1st power. I mean, you can, but it's kind of silly. We know that x is x to the 1st power, but when we add it all up, we're going to get x to the 6th power. So when we take this rule, this pattern that we see, it can save us a lot of time and a lot of space. So when I go over here to number 1, I mean, I could write 11 times 11 times 11 4 times 11 times 11 times 11 5 times. That gets a little old. What I know is I know that 11 to the 4th power times 11 to the 5th power is really 11 to the 4 plus 5 power, which is 11 to the 9th power. Okay, and then here's our answers for this over there. Now let's look at 2b. In 2b I have 5 times a to the negative 3rd power. Well, I know that 5 will stay 5, but a to the negative 3rd power, once again, is repeated division. So it's really 1 divided by a to over a to the 3rd power. Okay, so when I multiply this through, 5 times 1 is 5, and I know that 5 is really 5 over 1, and the denominator times the denominator will give me that. Okay, we're just doing multiplication. My final answer is 5 divided by a to the 3rd power, a cubed. So it's 5 over a cubed. Let's take a look at numbers 8 to 9. We're going to simplify these expressions where we're multiplying exponents. Now the first thing I want to do, what you might want to do, is I want to show you what's really going on here. Here we have the same base of y, but each of these bases has a coefficient. I just want us to realize what's going on here. Due to the multiplicative, well, actually it's the commutative property of multiplication. I would really read this, I could read it 6y to the second power, but it's 6 times y to the second power times 3 times y to the third power times 2 times y to the negative fourth power. So I can do some shuffling in here. Since all of my operations are multiplication, I can write this out like this. Oops, don't forget about my exponents. Oops, multiply that and negative 4. And then I can take, what I can really do is I can take all these coefficients and multiply them together. They're all being multiplied. So what I get is 6 times 3 times 2, and then I take my y bases, y to the second power times y to the third power times y to the negative fourth power. Now 6 times 3 is going to be 18, and 18 times 2 will be 36. So I took care of all my coefficients, and then all my y bases are the same. I just have to add up their exponents, which is 2 plus 3 plus minus 4, and that is a 4. Okay, and then I'm getting 36y, and then 2 plus 3 is 5, plus a negative 4, which is the same thing as minus 4, is going to be 1, which is really just 36y. There you have it. Okay, but you just add up these exponents here. 2 plus 3 is 5, plus a negative 1 is, negative 4 is just 1. Let's take a look at number 9. I've got c to the fourth power times d to the negative third power times c to the seventh power. I'm going to combine like terms first. C to the fourth power times c to the seventh power is really c to the 4 plus seventh power times d to the negative third power. Okay, so I add my exponents and I get c to the 11th power times d to the negative third power. Now I can work with this. I know that d to the negative third power is really 1 divided by d to the third power. And I bring down my c to the 11th power. And when I multiply this through, numerator times numerator, c to the 11th power times 1 is c to the 11th power. And then I can put a denominator here. 1 times d to the third power is d to the third power. And there you have it, okay? And just remember, you don't have to change these whole numbers into a fraction, but just so you know that I'm not breaking any math rules or what's going on here, I'm just taking this whole number c, whatever it is, I'm putting it over 1, dividing it by 1, which doesn't change the value. So when I go to multiply my fractions, it's just numerator times numerator. C to the 11th power times 1 is c to the 11th power, and then 1 times d to the third power is d to the third power, and we have it simplified all the way. Let's do one more problem. As always, I hope that was helpful, and if you have any questions about the remaining problems or the problems that even I went over just now, please bring those questions to class. See you later. Bye-bye.